Okay, today we will be doing the clipper circuit. Okay, clippers. Now see, what are the clippers? Clippers are networks that employ diodes to clip away a portion of an input signal without distorting the remaining part of the applied waveform. That means if you have a sine wave as your input like this circuit will clip away. Clip means cutting. Okay, clipping means cutting. Maybe let's say you want to cut this portion. Okay, you want to cut this portion like this. Okay, so you want to clip away this portion without distorting the remaining part. That means you cannot change the other part of the signal. Other part of the signal will remain like that. Okay, that circuit is called clipper circuit. Now next, let's see. The clippers can be classified into two categories. Number one is series, and another part is parallel. Okay, series and parallel, and we will be learning about both of them, series and parallel clippers. So let's see the series clippers first. What are the series clippers? Series clippers will be your diode will remain in series with your input and the resistor will be parallel. Diode will be series, resistor will be parallel. Now this particular circuit is your half-wave rectifier, right? Your half-wave rectifier is also a clipper. Why? Because see this. If you have an input like this, your half-wave rectifier will clip away this portion. Which portion? This portion. Your half-wave rectifier will clip away the half of it. That's why it is called a clipper as well. But you do not have enough control. Your half of it will go, not a small portion. The all half will be gone. Here you can see this half will be gone, right? This half will be gone. So only the positive half remains. That's why this is the simplest clipper possible. Simplest clipper. Okay, this is a clipper. So why this is called series clipper? Because your diode remains series with your inputs. Now let's go back. Okay. So here, what changed? What changed with this circuit? What is that? A voltage source is applied. A voltage source is added. A voltage source is added with the circuit. This circuit actually. Now, how it will change our what is that? How it will change our output? Let's see. Here, whenever you add a DC source with AC source in series, see here, this AC source, that is AC source means the input, and the DC source, that is this V, they are actually series, right? They are series. So whenever you add a voltage source, DC source with an AC source in series, what will happen? The shape will not be changed. The shape of the AC will not be changed, just it will go up or go down. If the voltage is positive, it will go up. If the voltage is negative, it will go down. What do I mean by that? See. Let's say this was your input, like this one, exactly this one. Now you want to add you want to add a voltage. So what will happen? So if you add plus V, your voltage will be like this. Your output, your input will be like this. Okay, your input will be like this. That means it goes up. If you subtract, if you subtract your, if you subtract, what is that? Subtract means if you, what is that? Do you know what is subtraction? Subtraction means biyog. That means the opposite of addition. If you subtract a voltage, let's say V, with your input, it will go down. Like this. So what is happening here? If you add a voltage, it will go up. It will subtract a voltage, it will go down. With AC, AC, see, the shape didn't change. The shape will not change. The only change will be the position. It will go up or it will go down, right? Understood my point? Here, what happened? Did we subtract or we add? Here we subtract. Why? See, this is your plus, this is your minus, right? This is your AC. With AC, what you have done? You have done something like this. So this is your plus, this is your minus. Now, if I draw these, if I draw this like this in a straight line, okay, let me clear the area so that you can understand better. See, for this source, the positive is in this way. For this source, the positive is in this way. Since they are opposite, that means they are subtracted. They are being subtracted here, okay? Not the addition, they are subtracted. So which one will be the case? This one or this one? Which one? Anyone?
It goes down, sir.
Yeah, it goes down, right? Very good, exactly. So if it is going down, so I'm going to erase the other. So this will be your input, right? This will be your final input now. This will be your final input now. Okay? Now, since, okay, I'm going to erase this, erase this. Since then you have a diode in forward bias, right? Forward bias means it is forward. This diode is forward. Forward means only the positive part, only the positive part will remain. This positive part and this positive part will remain. The negative part actually will be gone. Understood? How? Because this diode is forward. So the negative part, oh my god, will be gone. So the only thing that is remaining is this. Understood? So it clips away most of your signal, but that was what we wanted. That is what we wanted with this circuit. Okay, let's check. See, so most of the, okay, it actually goes down. It goes down like this. No, it goes down like that, and this part, that is the negative portion, is gone. So what you are left with? you are left with a small portion of your positive input. Now let's go and see here what will happen if I rotate the direction of the voltage source. What will happen? Again, these are what at the same direction. How do I know that? See, your AC is direction is here, your DC direction is also here, right? The same direction. So what will happen? They will add up and the input will go up. Here let's say it is 20 volt, right? Your input is 20 volt. Understood? Your VI input is 20 volt and your DC is 5 volt. So 20 plus 5, 25. So your input will go up by 5 volt. So now this will be 25, not 20, because 20 is added with 5, so 25. The starting point will be 5 because 0 will be added with 5. So starting point is 5. The highest point is 20. 20 is added with 5, so 25. The lowest point was minus 20. So minus 20 plus 5 is equal to 15. You got my point, everyone?
Yes, sir.
Again, okay. This is your input, that is 20 volt minus 20 volt, right? So 0, 20, 0, minus 20, 0 again. That was your input, right? If that input is added with 5 volt, why I am saying added? Because their direction is same. If their direction is same, that time what will happen? They will be added, not subtracted, added. So 0 will be added with 5, that is 5. 20 is added with 5, that is 25. Minus 20 is added with 5, that is minus 15. Not 15, minus 15. See here, 0 was here. Okay, this was our circuit actually. Okay. Previously, this was our circuit. This was our input. Right? So 0, 20, and minus 20. Previously, this was our input, like this one. But when this is added with 5 volt, so 0 become 5, 20 become 25, minus 20 become minus 15. Understood? Now what is happening? I'm going to erase this. Now what will happen? Since the diode is forward bias, only the positive part will remain. That means this part will remain. The negative portion will be gone. How gone? Because the diode is there and diode is forward bias. So let's erase that. It's gone. So this is your input. This is your output, not input. VO. This is your VO. Understood? Hello?
Yes, sir.
Yes, sir.
Okay. Faisal?
Yes, sir.
You understood, right?
Yes, sir.
Abdikani, roll 25.
Yes, sir.
Okay. Abdi Hakim. Abdi Karim, not Hakim.
Yes, sir.
Okay. Your role is how much? Your role is what?
My roll 54.
54. Okay. See, remember, you do not have to calculate a lot of things. Do not calculate, because we actually know if I add AC with DC, the input will go up or go down. That's it. So you do not have to calculate everything. Okay. So you will be calculating all these things inside your head. So this is the output. So it will start from here. Do you understand? It will start from 5, not from 0. See, it will start not from 0. It will start from 5. 5. This is 5 volt. See, this is 5 volt. The highest value is 25 volts. So 20 plus 5 is 25, right? 25. And this value will be 0 plus 5, that is 5 volt. So this will be your output now. Okay. Now let's see some parallel clippers. What is parallel clipper? Parallel clippers are when the diode is parallel. When the diode is parallel, what will happen? And we are taking output from diode, right? What will happen for this? In this case, it will be completely opposite what we have seen before. When the diode was here, the negative portion was gone. Since the diode is here now, this portion will be gone. This portion will remain. Why? See, in case of forward bias, that means in case of positive half cycle, current will go in this way, right? Current can go actually. When current can go, all the voltage drop, all the voltage here will be dropped in the resistor. So what diode will get? Diode will get nothing, because diode do not take anything. Resistor does. Resistor takes anything, right? Whenever there is a current, resistor will take all the voltage. So all the voltage will be gone to the resistor. What diode will get? Nothing, 0. In case of reverse bias, what will happen? Current will try to go in this way, but it cannot, because the diode is there and diode is for reverse bias. So no current will flow. So resistor will not get anything. All the voltage will be gone to the diode. So all the voltage is to the diode. Is completely opposite of the previous circuit. So if you use these, positive portion will not be gone. Will be gone actually. Positive portion is gone. Like this. Again, you can add a voltage source. You can add a voltage source in your what is that, with diode as well. This one is tricky. This one is a bit complicated. Okay, because you are adding the voltage source with your output, not with your input, not with series, in parallel. This is complicated. This will not bring your input up or down. If you have the voltage source here, then it could have been gone up or gone down. Understood? But in this case, this is different. This is completely different. So let's say, let's see how your output can be calculated. Remember, this input is this one, right? So this will be starting from 0 to 16, then reducing, minus 16, then again 0, right? Here, this one is 4. Let's draw a line to the 4. Let's say this is your 4, okay? This is 4. So when your input is 0 volt, that means at the starting point, when your input is 0 volt, this is 0. And how much is this? This is 4. So this diode is forward bias or reverse bias? Who can tell?
Forward.
Forward, because the positive point has more voltage than the negative point. What negative voltage has? Negative voltage is 0 volt, right? And the positive point is 4 volt. So this diode is forward bias, right? When it is forward bias, so current will flow, right? When the current is flowing, this diode is short. So how much your output will be? How much your output will be? So if you take a multimeter and if you place the red pin to the plus and the black pin to the minus, What will be your output now? Who can tell? Who can tell? What will be your output? Anyone? Any guess?
0 plus 4. It's 4, sir.
It's 4, not 0. 0 plus 4 is not needed. It's 4. Because
4.
you are actually measuring what? You are actually measuring this point. This point is actually this point. And this point is actually this point, right? So you are actually measuring this voltage, right?
Yes, sir.
So your output will be 4. So let's give a green line. So when your input is 1, when your input is 1, okay, again, I'm going to erase this. When your input is 1, is it forward or reverse?
Forward.
Yes, still forward, right? If it is forward,
Yes,
you will get
sir.
4. If it is forward, you will get 4. When it is 2, still forward, you will get 4. When it is 3, still forward, right?
Yes, sir.
You will get 4, right? When it is 4, that time, remember, that time it is no longer forward, it is what?
Reverse what?
No, it is no bias, not yet reverse. Reverse is not yet there. Reverse will be at the front. But when it is 4, it is 4, that means it is no bias. No bias means no current, right?
Yes, sir.
No current means it is open. It is what? It is open, right? When it is open, that means what voltage you are getting now? You are getting this 4 volt or this 4 volt?
4.
This 4 volt, right?
Yeah.
You are getting this
Yes.
4 volt. Why? Because current cannot go. So whatever voltage you are having here, this voltage will be here, right? If there is no current, see, is there any current now? Why not? Because this is open, right? If there
Sir.
is no current, so no voltage will be dropped here. All the voltage will be to the output. So you are getting 4 volt. Now, when it is 5 volt, that means when the input is increasing, right? When it is 5 volt, again, it is reverse bias, right? It is reverse bias now. Reverse bias means it is open. So whatever voltage you have here, that will be in your output. So 5. So when it is 6 volt, still reverse bias, you will get 6 volt. When it is 10 volt, it is reverse bias, so you will get 10 volt. When it is 16 volt, reverse bias, you will get 16 volt. Understood? See, it is going up, right?
Yes, sir.
When it is 15 volt, you will get 15 volt. 14 volt, you will get 14 volt. 13 volt, you will get 13 volt. 12 volt, 12 volt. Like that. When it is 5 volt, you will get 5 volt. When it is 4 volt, you will get 4 volt. Now, when it is 4 volt again, when it is 4 volt again, what will happen? This is no bias, you will get 4 volt, right?
Sir.
But when it is less than 4, let's say it is 3 volt, what will happen? It is forward bias again, right? It is forward bias again. So
4.
what voltage you will get?
You
4.
will get
4.
4.
So when it is 0 volt, you will get 4. When it is -1, you will get 4. When it is -2, you will get 4. -10, you will get 4. -16, you will get 4. Like this. So these will be your output. Understood?
Yes, sir.
Okay, let's see whether it is your output or not. Is this your output?
Yes, sir.
Okay, understood? See? So
Yes.
4, gone up, gone down, again 4.
Yeah.
So this is your output. Understood how to calculate the output? So if you
Yes, sir.
if you do not get the output yet, I suggest you to see the video whenever I upload the video. Okay? Did you see the last video I uploaded? Did you? Oh, nobody, right? Okay. You should. Now, we have a cheat sheet. What do you mean by cheat sheet? Cheat sheet means a sheet, 684 page. This is the cheat sheet of your course of clippers. That means all the possible clippers in the world, all possible clippers are here. That means if you memorize or if you understand this page, you will not have any problem with clippers. Okay? All the clippers possible are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many? 13 clippers. Among them, 6 of them are series clipper and 7 of them are parallel clippers. Okay? Hello?
Yes, sir. We
So
understand.
I'm going to
Yes,
say
sir.
something. 5 of them will come in your exam.
These.
Yeah, these from here, 5 circuits will come in your exam. 5 circuits. What I will do, I will
Final.
give you the circuit, I will give you the input, and I will say, okay, please draw the output. Just you just have to draw these or these. Understood?
Sir, you
Yes,
give
sir.
me like this circuit, then I will drop output.
Yeah, you draw the output. I will give you the circuit, you draw the output. That's it.
Okay.
Understood?
Yeah.
Yes, sir.
Now, if you excuse me, I want to take 1 minute break. Okay, I need to drink some
Okay,
hot
okay, sir.
thing. Okay,
Okay, okay, sir.
okay, please pause. Okay. So here, I want you to nominate, or I want you to select some circuit so that I can teach you. Which one you think? Okay.
Sir, the first one mostly.
No. The first one is easy. The first one is easy, right? Okay. Let's
Second.
try. Okay, let's try. Let's try the first one. Okay, here. This is what the diode is reverse biased, right? So for positive half cycle, current will try to go in this way, but it cannot, right? Because the diode is reverse, so current we cannot go. So since current cannot go, what will happen to your resistor? Because current is not going, so no voltage will be here, right? For positive half cycle. For positive half cycle, no current is going, so no voltage. So that's why what? No output, right? Zero output for positive half cycle. But for negative half cycle, see this. For negative half cycle, that means for this, current will try to go in this way. Can it go? Can it go? Hello?
No, sir. Like
No,
clockwise.
no, sir.
No.
Why not? Because see the diode. For negative half cycle, current will try to go in this way, right? And the diode is also in this way. So it is forward bias or reverse bias?
Sir, for what?
It is forward bias, right? Because the current direction and the diode direction is same. So it is forward bias. Since it is forward bias, so current can go. So if current can go, the resistor will have a voltage. What voltage? Whatever voltage you have here, you will have here. right? Because you have only one resistor. Resistor takes up all the voltage. So all the voltage will be in the resistor. So this voltage will go here. Okay? Understood? Hello? Understood?
Yes, sir.
Okay. Now, for next one, okay, let's say this was your input. Okay, let's say this was your input. What will be your output? We have done this already. So this is what? This is your diode that is this way. So when for positive half cycle, that means for this, current will try to go in this way. So it is forward bias or reverse bias? Forward or reverse?
Forward, sir.
Forward. Since it's forward, so current can go. So resistor will get voltage because current is there. If current is there, if there is a current, resistor will have voltage. So there is a current, so resistor will have a voltage. What voltage? Your input voltage, all of it. So this. Understood? For negative half cycle, this one, current will try to go in opposite direction, but it cannot go, right? So no current means no resistor voltage, no voltage. Understood? Like this. Clear?
Yes, sir.
Okay. I'm going to clear everything. Again, let's go back to the next one. Okay, let's do this. Okay, this one. Let's do this one. Okay. Here you have a VI, that means input. Here you have a positive V. So since they are series, they are in series, so they will add up. Here, why add up? Because this direction is this one. This direction is this one, right? So they are at the same direction. So they will add up. So your voltage will go up. Your AC voltage will go up like this. Okay. Your AC voltage will go up. So by how much? By V. So how much is this? This is VI plus V, right? How much is this? This is minus VI plus V. It is just going up. Now, what will happen? Since the diode is reverse bias, so the forward part will be gone. The only portion that will remain is this. This portion will remain, the red portion will be gone. See your output. Right? Understood? So your output will be like this. Understand, my dear?
Yes, sir.
Okay, very good. Now let's see one more. Which one? Let's try these. Okay, let's try this. So for that, let's create a place. Okay, now let's say this was your input. Okay, this was your input. Now what will be your output? See here, this voltage is not with your input, not series with your input, so that will be like the previous one we have done. Now here, see, let's say the input was from 0 to 10, from 0 to -10. Okay, so when the input is 0 volt, that time what is the voltage here? Let's say it is 5 volt. Let's say it is 5 volt. Okay, so it is positive 5 or negative 5 is at this place, at this point, positive 5 or negative 5?
-5, sir.
Exactly, negative 5. Negative 5, and what is the voltage here? What is the voltage here?
0 voltage.
Exactly, 0 voltage. That means the input. So here is -5, here is 0 volt. So in your diode, you have a voltage, right? Oh my God, what I have
Yes.
drawn. In your diode, you have a voltage. Here you have 0 volt. Here you have -5. Which one is bigger?
0 volt is bigger.
Exactly. Since it is 0 volt, that means it is forward bias or reverse bias?
Forward bias.
Forward bias. So since it is forward bias, what will happen? It will be short, right?
Sir.
When it is short, what will be your output now?
0.
0.
No. It is short. So when you measure the voltage with multimeter, so you put your red pin here and you put your black pin here, right?
-5, sir.
So exactly, -5, because plus is connected to -5, minus is connected to +5. So you will get how much?
Negative.
You will get -5. So if it is 1, you will get -5, 2, -5, 3, -5, 4, -5, because your 1, 2, 3, 4, up to 10, right? Everything is bigger than -5. Whatever voltage you have, everything is bigger than what? -5, right?
-5.
Okay, when it is reducing, so 9, 8, 7, blah, 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 up to 0, everything is bigger than -5. So you will get what? You will get the exact same value of -5 because the diode is forward. When it will reduce again, so -1, like here, -2, -3, -4, like that, -2, -3, -4, okay, still it is forward bias. So -4 is bigger than -5, right?
Sir.
Understood?
Yes.
So it is forward bias, so you will get -5. Whenever, oh my god, whenever whenever your input is -5, that time, what is this? This is no longer forward bias. This is what? No bias. When this is no bias, remember that time it is what? It is what? It is open circuit, right? It is
Yes.
no bias. So that time what will have? What you will have? You will not have this plus. This red means that time this one. Okay? And this black will be that one, because there is no resistance voltage. Got my point? That time your input will be your output, like this.
To again -5.
Again, again.
And
Hello?
up to again -5. Yes, sir.
Yeah, up to again -5. Then when the -5 will reach, again it will be -5.
Yes.
Understood?
Yes, sir.
Okay. So I believe you understood everything. The only problem you will have here, the most complicated circuit, this one, you will have problem here. Understood?
Yes, sir.
But I want you to learn all of this. I'm not going to teach you this today. Not today. Not today. I want you to learn all of it, because I told you, remember, this is a cheat. This is a cheating. I am telling you that I will be giving 5 circuits from here. 5. 1, 2, 3, 4, 5. 5 circuits. Whether it is online exam or it is offline exam, doesn't matter. I will give 5 of them. Okay?
Okay, sir.
Which 5 I do not know, but you have to learn all of this. Can you do that?
Yes, sir.
Yes,
Okay.
sir.
So tomorrow we will start clamper circuit. Tomorrow means Tuesday. Tuesday we have a lab.
Yes, yes.
In the lab we will see all the circuit in the Proteus. Okay.
Okay, sir.
So I want to leave now. So if you have any problem, you can ask me. Otherwise, I can leave.